hello for this week. Let's see who's in here. Let's get some music going and get stuff going here. All right, so last week we were working on the F Audio native implementation. So we're going to continue on that and then see how far we get. The goal being to get this thing to a committable state so we can move on to other things and get closer to having this thing ready. Gary Taro, next week I'm seeing if I can run the game on Xbox. Yes, that's always an interesting time trying to see how quickly you can get your game up and running on console. MonoGame helps a lot, but with every engine, even Unreal Engine or Unity, anything like that, there's porting and there's things that you don't account for and things that go wrong. So it's always difficult. So it's definitely worth testing your games early and often on console when you have the ability. Hello, everybody. Feel free to ask questions as we go. All right, so let's get to, as always, if you haven't already, make sure you follow us on Twitch and YouTube. It's important. We're trying to build up our base of viewers and, unlock monetization and, try to evangelize MonoGame more. So if you haven't followed us in either of those, go ahead and do it. All right, so let's get started here. Let's get my desktop shared. See, is that the right window? Yes, I believe it is. All right, desktop shared. Let's get going. So we're going to go with, where was I working before? That guy. That's where I was working. Hide you. Let's get our chat up and running here, because that's always nice. Test here. All right. That's all working. Awesome. All right. So where we're at is we were trying to fix some remaining unit tests, if I remember correctly. So we had the unit tests up in here. Was that in here? Oh yeah, it was in here. So we're running the unit test out of here, and whatever reason, it killed my unit test view. Test Explorer, there we go. And we were basically trying to make sure that all the audio tests run. So I'm going to run it again. Beeps, beeps. I don't know if you guys can hear that, but it's giving us beeps and stuff as it's running the tests. Right, so we had the X-axis tests were failing, and some of the dynamic sound effect tests were failing. That one failed as well. Not run. What's up with that? I guess I should probably fix any. I should probably add a message at the bottom, huh? Let's do that real quick. Let's add a ticker. There we go. Let's see, back to chat. So this is not working on a specific game. It's working on MonoGame, which is a framework, a C# framework for building 2D and 3D games across all platforms. And we're implementing a native audio backend called F Audio, so that we have a new backend that is cross-platform on desktops for Mac, Linux, and Windows. That's what we're working on. Let's see. All right, so pending buffer count. Why is this test failing is the question. I guess it's failing. This is not very useful information. There's a, basically it's trying to tell me that it wasn't run, and the question is why. So let's see what happens here if I debug it. Probably something is failing along these paths, and I'm sure dynamic sound effects are failing for some reason. The worst window in the world, that diagnostics window. Let's see, it's creating a buffer. That succeeded. Okay, so it gets past this, it creates the instance. And then submit buffers, buffer count equals that, calls play. Well, no, that's fine. Sleep while dispatching does this. Some exception is thrown inside of F audio. Interesting. Internal converts F16, F32. Interesting. Anything in the output window? Interesting. Let's see. Oh, I know what the problem is. I know what the problem is. So in the thread where it's running this, let's see. Well, I don't need to see that. So what's happening is that so it's generating a sine wave buffer and calling submit buffer, which internally calls submit buffer, which internally calls platform submit buffer after a bunch of asserts and stuff, then calls a pen buffer, which passes in this buffer, right? Just as it pins the memory, which is just holding on to the memory so it can pass it to native code. And then it calls that native voice pen buffer, which is in here for F audio. And what this is doing is the bad thing. It's just saying, hey, let me take this buffer, and I'm just going to pass this buffer straight into the F audio and say, go play it. Here's the problem. That buffer is owned by C#. We pinned it, which allows us to pass it to the native code. But after that native code returns, it unpins it, and the GC is free to consume it. So the GC most likely consumed it or moved it, but the sound system was still trying to play that same chunk of data, and then it failed because the memory either went away or is invalidated or something. So that's what's happening. So this does not work. We cannot just pass the buffer that comes in and do something with it because we're not holding on to that memory. And then how the native API was designed to make it easy to pass data down to say, hey, play this, but it's up to the native side to cache it and make sure that it doesn't go away while it's processing. So what we had before, no, that's not what I wanted to do. Oh no, I lost my pen. Pin it back. All right. What I was doing before was I was comparing the F audio and our X audio implementation. The X audio implementation, I can show it to you here, I guess. Let me just do it here. The X audio implementation, it's Windows DX, X audio. So that same voice pen buffer does something different. It manages an internal list of free streaming buffers. And the reason we did it like this and didn't do the streaming buffers the C# side was just that it's possible that the native code, depending on the platform, might have a more optimal way of doing it than C# might. So in this case, we push this work to the native code side. So the native code has to decide how I'm going to manage this buffer that I need to pass into the sound system. So our implementation for X audio was this, and the thing that I don't like about this is this static free streaming buffers. It was just kind of a hack. I don't love it. It's still not the worst though. I might take this design and rework it. I might make it at least live on the system instead of living in it as a global, just to make it a little bit cleaner. But it still needs to be something like that, where we find a free buffer and we consume it and then we return it. That means the native code can be free to pass pointers of memory down saying, hey, play this. And then the native code says, let me find a free buffer, and initialize it and play it, right? And that makes the native code more responsible for stuff. It can do things faster. Since it's native code, it'll be faster at finding a free buffer and initializing it and everything else than the C# side will be, and it lets us kind of customize it on a per platform basis to what makes sense for that platform. So yeah, so that's the reason we did it this way. So let's start with, I guess let's re-implement this in the F-Audio side. And then after we re-implement it on the F-Audio side, then we'll probably backport it to the X-Audio side so we share the implementation as much as possible, or the design of it as much as possible. So on the F-Audio side, we are going to replace this with, we're going to throw all this code in here. So instead of finding a free buffer there, let's go get that streaming buffer array. Instead of putting this thing up there, we're going to put it in the system. Call it that because that's nice. So it's now part of the system. And then in here, well, not there. In here, we're going to use it like this. I sort of like not. So the voice has a pointer to the system, which then has our free streaming buffers. And I like to use a reference like this for stuff like this. Make it a little bit cleaner. All this code should be the same. So it's going to find a free buffer. It's going to initialize it. And we're keeping an array of these buffers and not like, in theory, we could keep another structure that's more optimal to the platform. But in this case, it probably doesn't make sense because it's just a chunk of memory, and this already has some work there to, handle that chunk of memory. So, yeah, so it's probably best this way. Let's see. This is probably, what is this doing? Voice get state if it's not playing, return. I wonder what this is about. Why would we take the time to get a buffer? That's curious, huh? I have no clue what this is there for. I mean, it got the buffer, and then it kind of said, let me jump out of the function without doing anything with the buffer. Buffer isn't even attached to anything. It's like, oh, it's gone. That is curious. Curious and not ideal. I'm surprised. I wonder what this. I guess the idea here was that if it isn't playing, then there's no reason to submit it. But it didn't do anything with it. I don't see it. It didn't add it to anything. So it's not like it's. Yeah, this design is a little bit mixed up, maybe. It's thinking like somebody might call a pin buffer a bunch of times as different buffers, then call play later. I guess is the idea, but it's not doing anything with it, which is a problem. And I don't even know if this pattern actually occurs, really. How we have things implemented. Maybe it does. I guess it does, but right? Because sound effects instance has submit buffer, which can occur at any point. It doesn't have to be playing for this to occur. There's probably a mistake in this, that it's not handling that. It should probably hold on to any pending buffers and take care of submitting them. I mean, even if it's not playing, I forget how that works with X-Audio. I think with X-Audio, I think you have a limit, but I think that you can. I don't think you have to be playing to submit the source buffer. Yeah, I think you're free to submit source buffers up until. Yeah, I think you're free to do that. Let's see. Let's see what official documentation says. Processes and plays back the buffers in its queue order submitted. If the voice is starting has no buffers queued, the new buffer will start playing immediately. If the voice is stopped, the buffer is added to the voice's queue and will be played when the voice starts. Okay, so you can queue them into the system, so there's no reason that we couldn't have done that. So I don't know what this, if it's not playing, don't do it thing is. It seems perfectly valid to do that. There's a little concern I have over a leak potentially there. So let's see. Yeah, so let's not worry about that implementation as much. We're going to get this one right, and then we're going to work back up to the other one. So this is, to me, I call bullshit on this. It doesn't care what state it's in. It can be stopped, it can be playing, it can be paused. It's fine to submit the buffers to the system. And instead of doing it like this, we're going to do it like this. Because that's defined here too as an F audio buffer. Yeah. I think in this case it is explicitly making a copy. Call it F buffer. That's nice. And nah, I'll just call it X buffer because it's hate the fact the word buffer is used so much everywhere here, but it just is. Let's just call it buffer. So I'm going to share that code later. We're going to copy the buffer structure. I did this specifically because I want to make sure. The reason I put a comment here, say copy, it's like, oh, it looks like what you're doing. It's like I want to make it clear to somebody this is not a pointer to a buffer. We're copying the buffer in this case, or copying the structure of the buffer. Why doesn't it like all this? Is this the wrong thing? That's the right thing. What is it not like here? Oh, it's because of this. Annoying. B buffer. I'm trying to keep something generic. I don't want to call it X and have to fix the other one. The more similar I can make this code to what we're going to end up with in the X audio code, better. So we're going to submit it, and the submission works a little differently here. So we might actually have to fix the size, maybe. No, well, yes. Yeah, we need to fix the size here too, because we might have grabbed a buffer that was bigger. Like it looks at the free list and finds one that is at least the size that we require. But it could be bigger. You don't need that there. Just cleaning up code as I go here. That comment was interesting. I had written this originally. Yeah, like one idea was, instead of allocating like a bunch of small buffers, is for dynamic streaming, just allocate one big buffer and then, subdivide that buffer as needed. That sounds nice, and it is like take some pressure off the memory allocator and everything by doing it like that. But this is a little bit more flexible, I guess, by having lots of smaller buffers, even though it's a little bit more overhead. But I don't think that overhead is actually concerning. I think it's all pretty negligible. This kind of like micro optimization of trying to optimize something very, very small that probably doesn't really help very much in the end. But sometimes your brain goes there thinking about that. So, all right, so what we're doing. So we have this, but one other thing we found was that we need to update the size. Is that byte size? Nope. I think that's the actual size. It's just the comment is. Okay, yeah, that comment was written. How Ethan wrote this, or how the F-Audio team wrote this, was kind of dumb. They put this comment here, so it keeps bringing up this documentation for this entry, even though this is separate. That's the actual number of bytes. And it's like, I get that's the count, but it's not documented, and the name of the variable makes it, hard to understand. So anyways, so that's the actual size. We're replacing the size. Since we made a copy of the structure, we can change the size to be whatever it's supposed to be for this buffer and play. So this should now submit it properly. But that's a submission. We still have to do is we're passing this in here and passing this, like part of that structure is a context pointer, which lets you pass any data you want to the sound system. So what we're passing there is actually the buffer itself, our buffer. The reason to do that is so that when the sound is consumed, we can then recover that buffer and throw it back into the free streaming list. So that's what we need to do next, is we need this to recover. And if I go back to the X-Audio implementation, what we did was, here it is. Nope, that's a different thing. We need to do this though. So let's do that, I guess, while we're thinking of it. In the system, we're going to get rid of, I don't think we need to explain this any further here. So part of the system, when we're going to destroy the system, we don't need to do anything else there. This is to take the system buffers and destroy them. I'll destroy them one at a time, which is perfectly fine. The system should be stopped with everything. I mean, that does bring up the question if we should go out of our way to stop all the playing sounds at this point. Let's put a note. I mean, in some ways, when I'm working on this native stuff, I consider two scenarios. One is our immediate needs, which our immediate needs are to make this work with MonoGame as it is right now. Knowing that the consumer of this native API is the low-level native C# the C# native backend for MonoGame. That's the first and primary consumer of this API. But moving forward, technically this native API could be reused by anybody for anything. It's just basically a low-level wrapper for rendering and everything. And in theory, at some point, we could maybe not spin off, but expose the native API so that others could potentially use it for their own backend for something else. And that's totally viable, so always consider like who's the consumer here. But right now, our primary consumer of this API is MonoGame C# code, so it should work the way it does. And I'm pretty sure the MonoGame C# code, when it destroys the sound system, the first thing it does is it makes sure all the voices are stopped. So do we need to do this? Possibly not, because the C# side is going to do it for us, but something to consider in the future. Anyway, so back to what we're doing. So we saw that, but we were also looking for, this is what we're looking for. So there's a callback system that X Audio has, and I assume F Audio has as well, if it's a full reimplementation, which I'm pretty sure it is, that this callback will get called when on some case. And one of the callbacks is when the buffer ends, it makes the callback. Well, this is where we're restoring those back to the free system. Now here's where we see why was I doing this in a way that required a global, was because of this callback, right? But I don't know if that's true or not. Okay, so the buffer doesn't keep track of the system, but it totally could. It's just an extra pointer. It doesn't hurt anything. So I don't see a pointer with it keeping track of the system. So that's probably what I'm going to do here is have the buffer hold on to the system so that the buffer can then know, how to get back to what it needs. I'm going to do it like this, and then we're going to fix up our cases so that it works correctly here in a little bit. Again, extra pointer, 8 to 4 bytes depending on platform, 64 bits or 32 bits, and it totally works good enough, I think. So, so the callback system. Where is it? So this voice callbacks we need to set up. In F Audio, we should probably put it in the same place I put it last time. Put it right before the voice create, because it's kind of related to voice stuff. Let's clean up the naming. Voice callbacks. I'm sure this is like F Audio voice callback. It's not a 2. I guess we're gonna have to find it. They called it that. Even though it is technically an interface, they called it that, so that's fine. Okay, so those things. So the API is slightly different. Let's go figure it out. Really hate when I get why this happens this way, but it's really annoying. So voice start requires that. Is it voice start? Voice processing pass start. Pass end, I assume, is correct. End is correct. Buffer start, loop end, voice. So on voice error is different. It takes a callback. So there's a couple little differences in this implementation, which is fine. Hello, Crumpet. Sure. All right, so that so a little circular here, but it totally works. So that will be how it gets that stuff back. The callback handler is kind of can be static like this. It sort of makes sense because it is kind of global. We don't have more than one system, but it is kind of global. It works with anything because it's not tied to a particular system or anything. You know, the other way to do this, actually, that I didn't have to do it this way. Yeah, let's do it maybe more properly. That would probably be a good thing, I guess. Well, let's see. Let's see where we get it. So this thing is passed into, so every time it creates a source voice, it passes in the callbacks handler, which actually is a little bit inefficient potentially, you know, because I don't know, I guess the sound system has to handle it whether it has one or not. But it should be like every time it plays a buffer, it would have to check, you know, oh, does this voice have a callback handler? It does. Okay, I need to call the callback. So it has to do a little bit more work on every buffer, but I don't think it's too much work. So it doesn't hurt to just do it everywhere. In theory, a more optimal thing would be is if I know this voice doesn't need the callbacks, like for instance, it's not a streaming buffer, it's not a dynamic buffer, or a dynamic sound effect instance, then I could say, well, I don't need the callbacks, and it gets rid of that overhead. But I think that overhead is minimal, and it's probably better to be more generic like this. So yeah, that's probably a better situation, I guess, versus trying to handle it differently. So until you see some pointer, this callbacks handler, we might just clean this up a little bit and not use this global for any reason, because that's really not necessary. So yeah, let's do a couple things here. All right, doing it live. We're going to do this, and we're going to do that, which is fine. So this is one of these chicken and the egg things, huh? Let's make it a proper class. I don't need to do that, but oh, that's an interesting idea. I had a more interesting idea. Duh. Check this craziness out. Is that allowed? I guess that would be allowed. I could do that, but I might have to make this a class instead of, but I guess it doesn't matter too much if it's a class or struct. From the outside, it just cares it's a pointer to something. It doesn't really matter what it is. So it might not matter. I like this design maybe, but because then the callback itself is the system. That's kind of an interesting approach, but this is probably safer. As much as I like the idea of doing it the other way, this is probably better. So what will happen in here is it will have yep, that's what we're going to do there. And then there won't be a global anymore. And then this will have a system directly. Again, a lot to just fix this one thing, but it was like, seemed nicer than larding up every buffer with a pointer back to the system that it doesn't really need. So that's a little bit better, I guess. With classes, I like to word my type so I know that what it is. All right. So yeah, that makes sense, I think. It's probably not going to like this. Yeah. Pre-declare that. Move this guy down here. Part of system create is then going to also be to create the create the callback system. And of course, down in here, all right, so that's better, I think. This thing's still in debugging. Probably could have turned that off a while back. All right, so with that, we have a callback system that knows the system. It is created as part of system create. It's freed. So the next step is on playing a voice, or creating a voice, I need to add this guy in. So where is it? Voice create. I think is that the only place? I think we create a voice in two different places. Set buffer creates one, and this. It's a little, I think this case is always the streaming case. So in theory, I could just put it here and not on the other case, but I'm not sure. I'm just going to do it on both, just in case. It's the third from the last, so. I'll do it on the other one here too, even though I think this case is not used in a streaming system or streaming setup. Yeah, if this isn't used in the streaming setup, I might prefer not to use this one, but we'll see. So I want to separate points on these guys because I want to see these guys being called. Yeah, I think this is the only one that uses it because it creates the format here for this specifically. This is the format that's required for streaming. Specifically for that, so I think I'm not going to put the callbacks on this guy. I think that's totally fine, but at least only ones that require this are the streaming sounds, which makes sense, I think. So yeah, let's verify that, but I'm pretty sure that's the right thing to do. So we're going to go back up here and let's set a breakpoint back on our callback so we know when the callback's called. I kind of want to see it happen. Now, I think one thing about this that we need to be a little careful about is threading, because I'm pretty sure this is going to be called on a separate thread than the other system. So that's something we have to be a little careful about here, because it could be that you could be trying to play a sound effect at the same time. Hey, hi, Iris Turtle. Could be trying to play one at the same time as trying to get one. So we need to be a little careful here. Let's set a couple breakpoints here so we can. Oh, that's not what I wanted to do. Get in the habit of hitting F5. No, don't run tests. No appropriate debug. Oh, we don't need you no more. We don't need you no more. All right. Debug. Creating the system. So that creates our voice callbacks. And then here it's creating the dynamic sound effect instance, which calls specifically this one with this callbacks. Pinning buffer count. We know this works, so I'm not going to worry about this. Or this is the test code. Nope, didn't like that. Oh, it doesn't have a buffer. What does it need? Oh, well, this one, in theory, it should always be the same format. It doesn't need to poke at this to get the format. In theory, it knows that it's the same format all the time. Don't we have like a format or something like that on here? What do we have? We did something. What was it? It was something when we create the voice, wasn't it? Maybe we don't do anything. We just assume that it's fine. Or we assume that, you know, it'll just be reproduced. Yeah, I mean, we create a format, we don't store it or anything. We just pass it into the, and say, here's the format, whatever. Actually, we do need this because the sample rate can change. Yeah, because the sample rate can change. It actually, if it's stereo or not, can change. Interesting enough. So we're sort of missing that. Or maybe we're not missing it. We'll see. Yeah, it passes the channels in and that. So it's not necessarily that. So that's another thing to consider. We need to consider. And I think that our streaming isn't even considering that. It's assuming that all the buffers are the same, and they're not. It's looking for something very specific. Let's do a couple things. One, let's hold on to the format in the voice itself. So the voice always has a format. At least for the streaming case. I mean, we could maybe get the format back out of this voice, but that seems kind of crappy. Oh no, back. Take a reference that format. So this comment is totally bullshit. I should have read that. Referring this format one time for that. And that is creating the voice. And then the format is here. So where we crashed here was down up here. So we can do voice format. I've gotten into a habit of using auto in places. Kind of want to use it sort of like we use var. And I just need to either use it or not. I've got it mixed. Like some places I'm using, some places I'm not. I'm going to use auto like var in C++. And that's probably the best thing to do. Or in C#. So that creates the right thing based on the right format. I'm not going to worry that format's not defined for non-streaming buffers. It's probably okay. Let's pretend that it's okay. I'm going to run this again. All right. So debug once more. Actually, you know what? Let's do one other thing. Just for, like, it doesn't have to do that. That's part of the format, if I remember correctly. Wait, no, what is that? Bits per sample is already... Let's see. Buffer, wave data, offset, size, sample bits, sample rate. Okay, so that's wrong. Channels, sorry, look at that. So this is supposed to be over here. Sample sec is supposed to be there. This code is wrong on the other thing too. Next audio. Yep, it's wrong here. Not good testing. Yep, probably never run the unit tests on it. It's okay. We're gonna make this one right and then fix the other one. Note that X audio implementation is also shared on Xbox, so it's broken on Xbox most likely as well. So that's not good. All right, so let's test this. Hey, look, we got a spammer. Block. Fast rammer. All right, so it creates this guy. We're gonna have to fix this because it's not gonna work well for that. We need to actually compare and see is the free buffer that we found the right format, because in theory you could have two dynamic sound effect instances that are different formats, you know, and they need to be able to get the right data for the right format. Didn't like that. What did it not like? Oh, it's probably that, yeah. Wave data can be null. That's the incoming wave data pointer can be null. That's acceptable. Because down here we check. Size is necessary because we need to do it, but the incoming data can be null because it's not necessarily going to copy any data. Why do we do it that way? Why don't we just pass the data through? Oh, because it depends. Some buffers, we do it this way because sometimes it wasn't created. It was gotten from the free thing, so we need to copy it anyway. So it was just easier to have one path. But yeah, so let's go fix this guy. That is allowed to be null. Stop it, run it again. Almost through this test. Ooh. So we initialize the buffer. Looks correct. Copy the data. Change the size here. Set the context, submit source buffer. Hit F5. Then it's going to hit play. And what did it not like? Insert submix sorted. Access violation. All right, insert submix sorted has an access violation. So we're gonna have to go look and see what the deal is with that. I'm gonna have to go look at the F-Audio source code and see what's going on. Oh. All right. Hard to say exactly what it didn't like here. Submix voice, I wonder. Yeah, I'm not sure what failed there. Wait, remove audio device. Where are we at? Run thread, remove audio device. Free effect chain. Free effect chain calls insert submix sorted. Okay. I guess we must have been shutting down or something. Dispatching. So we were dispatching and it decided we're removing a device. That's interesting. I wonder if it crashed further up or something. What that's about. That's kind of weird. Maybe I disturbed it with my debugging. Let's see, I'm going to remove some breakpoints here. No, still didn't like it. It's got to be me. It's most likely something I've done. Let's look a little closer here. Let's look a little closer here. Come on, let's get this thing done. So that's the buffer. Oh, wait, no, it's not there yet. Flags, bytes, audio data, play begin, loop count, context, play length. Is play length required to be a size? No, I think that's, if it's zeros, it assumes the whole buffer. Loop count is 0. Here's the data. I don't think there's any flags that have to go on there. Let's see. Let's look at our implementation for. Yeah. Yeah, any of that. The last argument here. Yeah, it's not that. The buffer is temporary. It's constant. They don't. It makes a copy of that structure internally. It's possible this call stack doesn't make any sense. Internal resample stereo, free effect chain. Submix voice. Let's go look at free effect chain real quick. Where that is. It was in the same place we were already at. Yeah, like I thought. Like the call stack doesn't make any sense. Free effect chain does not call insert submix voice, so it sounds like something else is going down here. It's hard to see where the freaking line code is. There. It's just updating the dispatcher and sleeping. Probably something simple. I mean, reading location FFFFF, like that's very, very specific. No, it's not notifying me anything. Yeah, it's really screwing up at the low level. All right. As much as I hate it, I might actually just have to go build F-Audio to debug this and figure out what the heck's going on, because it's not giving me any information as to what's happening. The call stack is not. I'm just going to run it. I'm sure it's going to fail. Didn't hear any audio, and it failed. But it, I might let's take one more try at seeing if we can fix this by just examining things carefully. Let's look carefully at things and see if we missed something, because it must be that we missed something. Actually, is it possible? No. Use filter, default frequency ratio. Let's check the creation of the PCM buffer, because that could be something that's wrong somehow. Do a little bit of assertion here. Let's see. All this looks correct. Creates the voice. The result is 0. Pass in our callbacks. Is our callbacks ever called? We've never seen a call to the callbacks. Oh, wait a second. What the heck? That's not a good sign. I think it's not building. And it's just, damn it, this better not be what's going on. God damn it. Project only, Ribble only, desktop VK. Oh, look at that. That's not the right function. Why did it let me compile that then? Oh, wait a second. Am I doing this completely wrong? Okay, it's expecting a structure with pointers, and I'm passing it an allocated class. That's what's going wrong here. Their implementation just doesn't work the same way. It doesn't use an interface and a callback. Aha, that's probably what it is. And it's freaking out because it's like, what the heck is this thing? It's not the right thing. Yeah, I mean, a question from some, or not question, I guess a comment. No matter the program engine or library or anything behind it is always C++. I mean, that's true. I would say 90% of the time. You know, obviously you mean C/C++. There's a lot of things that C and not C++ under there, but yes, it's a C-based it's a C language underneath the hood on most everything. There are some things that actually go down to native or to assembly, you know, machine language stuff. There's some stuff like that, but the low level's been C++, you know, for decades now for almost everything, you know, exclusively. And I think Microsoft at one time was trying to push more C# internal to Windows and use it for more low level things. And games use it, you know, a lot. But yes, underneath the layer, there's C++. You know, underneath C++, you know, there's also bits of assembly and things like that in there. So it's always a mix. There's always a higher level, you know, but yes, that's true. So yeah, so this is totally different. And that's really annoying because that means the implementations will be different on both of those. But, and yeah. So what needs to happen here? Okay. So I get what's going on here now. So like all these guys, looks like all of them get a pointer to the voice callback itself. Okay, this is kind of, I mean, I know why he did it this way. He just doesn't have the luxury of the interface system from XNA. So for that reason, you know, he had to come up with a different system here. I don't know if there is. I think with Xaudio, or the Xaudio implementation has to be this other way. But yeah, everything takes a callback pointer. Okay, so what's going to be the best way to do this? I'm going to do this like this. Ugh, all so gross. Don't like it at all, but it'll work. Okay, this means that I can maybe optimize a little bit here. Yeah, I just have to do something a little different for X audio versus do something a little different for X audio versus F audio. But man, so close. Now I have to kind of rework this. So what I'm going to do is this. I'm going to keep this class, but it doesn't need to derive from anything. I'm going to keep this pointer. I need that there. I do not need I could use that, and it's going to be that. I'm just going to do it gross, and I'm going to go for there. Actually, well, no, I don't want to do anything too gross here. Ugh, super gross. I want to do this. Okay. Trying to formulate in my head what I'm doing here. So derived from this, it's going to keep this guy under here. It's going to construct itself. And then it is going to assign these variables back to this guy. Wait, can I do that? I might not be able to do it like this. I mean, I can if I keep it as struct, I guess. This will be first in the data, and then this will be second. Then in here, I'm going to do then these guys. The rest are all going to be null, which might save us some processing or something. This is annoying because we were so close. It's because that implementation is different. This will be the best way to handle this, I think. So all this still works the same. All right. So this should stop crashing, I think. Yeah, let's try it. Let's try it. No, that doesn't look positive. Oh, it's just a warning, but let's fix it while we're here. All right. So assign that pointer. These all are going to be null. Let's create this buffer. I think we're good there. We're going to leave this pointer in there. So initialize that. We're going to play. We got audio. Got to the end. I heard some static, which is annoying. Don't know what the deal is there. Got to the end of this. Oh, this breakpoint. Pending buffer count still equals 1. Okay, we got closer. Pending buffer count didn't change. Let me just run it. Played a little static there at the end, which is interesting. I wonder what that is about. It didn't call my callback. Is there time here? Bad. I have to go look at how pending buffer count is implemented, which is probably down in here. I guess say get position. Get buffer count. Let's get buffer count. And give it enough time to increase sample rate, channel count, length. I don't know how long it's supposed to be. That milliseconds. Let's give it 2 seconds instead. Let's see what happens. That's interesting. Why would it be doing that? I mean, hearing, I don't know if you guys can hear that or not, but hearing garbage is usually bad. So there's the buffer end though. You got to that. Pending buffer count was right. There's something wrong with the buffer size. Oh, that's supposed to throw. Okay, good. So something wrong with the buffer size. That's basically what it comes down to. So let's go look and see. So this successfully got here and freed the buffer, put it back in the list, I think. Let's go look at I'm gonna step into this guy again. That's a size in bytes of the buffer. Create a new one. It's allocating it size in, oh, that's probably, well, no, length. It's there. Length. Creates a format for the guy. This and random squigglies here. Get data length. Malloc that length. Wave data length. Yeah. Duration length. It's fine. Whatever. Audio data gives it length. Go look and see, just for shits and giggles, the size of this buffer. The size of that buffer is that size. No offset. Count is the same as the buffer. In this case. So, just for shits and giggles. Here's that data. It's the incoming buffer. Let's look at the first 100 bytes just to see what's going on here. I mean, whenever you're checking if a mem copy is working right, you know, you might be off the rails. Yeah. It should be the same as free data. Yeah. Everything here looks right. Why is it giving garbage there at the end? It should have said, okay, the buffer is done. You know, unless there's actual garbage at the end of that buffer. It's the only thing I can think of. If there is garbage at the end of it. Let's debug again. Man. Hearing rubbish is better than hearing nothing, though. Yeah, I mean, I guess it means we're getting close, but it does mean that I'm behind because I was hoping that we'd already be done with this and off to other tests by now. So that's not good. So what I want to do is I want to look at this buffer in particular, and the length of it is that, which I hate doing this, but I'm going to freaking do it. So let me change it to 16-bit. So I'm going to change it to a short pointer, and I guess I need to do this by half. Can I do that? Oh yeah, that's the number. All right. So we can see it rise, and it's a sine wave. So we see it rising and falling, rising and falling, rising and falling. So that looks like sine wave data. Do we get garbage at the end? No, looks like it's doing what it's supposed to do. Rise and fall. It must be I mean, it must be how we're. I mean, it must be the audio bytes is. I mean, audio bytes is correct. It's either, if it's not this, then it must be the voice itself. Everything there looks correct. Average bytes per second. I mean, is that accurate? I think I'm supposed to be generating one second of audio. I mean, the math works out, 44 kilohertz, 2 bytes per sample, 2 channels. Sort of makes sense. Just curious. Does appear to be mono. Are you setting 2 channels instead? I mean, that's a good question. I mean, so like going back to the unit test, it creates a stereo. This unit test has been here forever, so it's hard for me to believe that that's the problem. But it creates a stereo sound effect instance at 44 to 100 kilohertz. And then it generates a sine wave at that. Length is in seconds, so this code is supposed to generate 1 second of audio. Here's the frequency of the sound wave, but here's the sample rate, here's the channel count. So it's supposed to be creating an array of that size. I'm assuming this code is correct. It's been here for a very long time. So that's interesting. Buffer is that size. The amount of bytes. That's interesting. That's interesting. Buffer now has garbage in it. Why would the buffer now have garbage in it? Oh, it's a different buffer. Yeah, it's not the actual audio data. That's why it looks like that. But in theory, I can go back and do... Okay, no garbage in it. It's good to verify. No, this is normal. In theory, that test passed. Why we're getting noise at the end is the weird part. Buffer needed event handler. I forget how that buffer needed is called. I think it uses the where's my freaking, oh, this test still running. Buffers need his written one. Yeah. This code is all kind of crazy. I always hate looking at it. Agreed. Could be that this implementation does not work properly for a native. Yeah, this might just be something this is not handled properly for native. Like this buffers needed, this check buffer count's only called in one place on play. My guess is that this should be happening more often, and that most likely, if I go look at like any of the other implementations, so this might be where it's failing, is really it's that the native implementation for the dynamic buffer is not set up properly. Which I'm sure we've never run the unit tests on DirectX because the unit tests have been off for the DX12 backend and for the Vulkan backend. That means that we're not aware when something is broken, which means this, which is possible what's going on. Let's see real quick. Go to Windows, no. Audio. Let's just look at X Audio CS here. Yep. On buffer end is supposed to call check buffer count and see, you know. So basically it's assuming that the end buffer event was going to update, you know, the, hey, how many buffers are, you know, how many buffers are required. Yeah. So that's the problem, is there's some API missing here. Now, that's not the, why are we hearing noise? I don't know. That's a whole other freaking problem. That's a different problem. This problem, though, is that we don't have the right, the API is not structured properly for this thing. I thought audio tests ran on the self-hosted agents. I know they don't run on the hosted agent cards, but that's just the OpenAL stuff. Yeah, I mean, I think we're not running the Vulkan backends tests, and we're not running the DirectX, the DX12 backends tests, is what I think. We still don't have those enabled. And if we don't have those enabled, then it's not going to run those unit tests. And if it doesn't run those unit tests, then we don't know that things are broken. But yeah, so so the check buffer count, what it ends up doing is it looks to see what the pending list is, and it keeps track of this. Hey, our buffer is needed, thing. So it can say, hey, our buffer is needed, and buffers needed are used in update queue to say like, hey, if the buffers are needed, then. So yeah. So something needs to be here to update the buffers needed case. Because somehow we need to know out here that buffers are needed so that it can call the, so that it can, oh, it needs to call this handler, basically. Sorry, I missed this because of that. So basically, it needs to call this handler from the main thread whenever it says, hey, we're missing buffers. But why doesn't it just... This all feels very circular. I mean, basically what it's doing is it would wait till a buffer ended playback and then say, okay, we'll increment how many buffers we need by 1. Then here would come in here and say, if buffers needed is greater than or equal to 1, or greater than 0 is what it means. Greater than or equal to 1. Okay. If it's greater than 0, then calculate how many we need, and then call the need handler once per buffer that we need until it gets done. So Square Bananas posted, some of the audio tests rely on stopwatch durations. It's worth testing without breakpoints as well. It doesn't explain the noise though. Yeah, it doesn't explain the noise. I expanded the test to be longer, but I wonder if this is just a behavior that is different on that. Okay, well, I'm thinking of it. Stop this real quick. Where is it? If I run this, 1 Mississippi, it could be that, that's kind of interesting. It could be that F audio doesn't handle well if it runs out of buffer data. Like you have an audio piece of, you have a voice that's playing and it runs out of buffer data. What is it supposed to do? Well, I think under X audio, if it runs out of buffer data, it just stops, or it doesn't stop playing. It just plays silence. And it could be that this is not doing that. If it runs out of buffer data, it just plays random garbage. I mean, that seems pretty bad, but I guess it's possible that it does something like that. And that could be the reason why we have noise there. But that doesn't seem like a very good thing for it to do that. I mean, it sort of sounded like after 1 second, it played garbage. I'm going to play it again. Again, I don't know if you guys hear that, but it sounds about 1 second. If I go back to the unit test and shorten it again, it was, it was giving it time to finish, so it's going to wait like a little over a second. Let me just give it an exact second and just run that and see what happens. Okay. It was too quick because pending buffer count, probably return 1. That's probably what that failure was. Yeah, 0 expected 1. Too quick that it stopped it before it got a chance to actually The test used to be this. Sorry, this. Didn't get enough time for the. So the pending buffer count didn't get decremented in time here. Yeah, I mean, that's an interesting idea. Is to cue it more than once and see if the sound goes away. So I can do this. But this test is not going to work very well. But we'll be able to see if the sound, gets better. And that unit test, that's going to fail. Okay, let's disable you for a second. No, interesting. Even though I submitted 2 buffers here, still got garbage after the end. That's interesting. It's almost like it's going past the end of the data somehow, even though the length that I pass it is correct. I mean, I wonder if it's something dumb like it's not expecting length. I mean, it says, audio data bytes, or it says audio bytes is the length, wherever that is. Come on, thing. It's yeah. Where are you? Audio bytes. Interesting. Check my play. Yeah, play is a problem, but yeah, that's weird. I don't have an answer. Don't have an answer, which is very annoying. We might have to live with that as a bug for right now. Yeah, we might have to live with that as a bug for right now because I don't know the issue is there. It's really strange though, because it should not be running out of data. It shouldn't be overrunning the end of the band of it. We're saying play this, you know, and for sure it's running out of buffers. Unless it's something else, like if it's like if you use the callback, it's not going to work or something. I don't know. It's kind of strange. Kind of strange. Thank you, Dennis. 947. Love MonoGame. Thank you. We love you back. Well, let's get back to the other issue because that's going to be more productive, I think. I think this will run and it'll give noise, but it's going to succeed, I think. No, it still didn't succeed. That wasn't enough time. It's like it's super... So pending buffer count isn't updated in time for this thing. Like I give it one, you know, that's curious. Like if I give it less than, like, I guess it's going to fail there too, right? Oh, damn it. That's not what I wanted to do. Still failed. Pending buffer count is still 1. It must think the data is longer than it is. It's got to be. Because it's playing past the end of it. That's why we hear garbage. In fact, I guarantee you won't hear garbage if I do this. If I change the length of this to 2, we're not going to hear garbage. Right? But it still failed because the pending buffer count was still there. So it's like... somewhere, it's a difference. It must be a difference in how F audio works. It's got to be. There's something I'm getting very wrong. So notice how, like, okay, so here's the thing I was noticing. So I'm going to run this again. I'm sleeping for 1.8 seconds, essentially. But it's still failing here. Still failing here at this line because the pending buffer count is still 1. Well, the buffer is 1 second long. Why hasn't it finished playing that buffer? Well, it's still playing that buffer. It thinks it's still playing the buffer. It's going past the end and continuing to play data. That's why it's waiting so long. If I set it to a little bit past 2, actually, I'm going to set it to 2 exactly. It's probably going to fail. Might not. We'll see. Yeah, still failed. If I set a little past 2, it's going to succeed. Sound like garbage, but succeed. Because it thinks it's still playing the buffer. It's like, oh, the buffer's, it thinks the buffer's 2 seconds long when the buffer is actually 1 second long. So why does it think that is the question. You know, it's got to be in here. We're giving it the length in bytes. It's got to be either, I mean, the buffer format doesn't matter. The length is the length. It's got to be the format that we're giving to the audio, to the voice. block alignment, bits per sample. Samples per second. Average bytes per second. I'm just going to do this. Let's see what happens. I think that's going to work. Yeah, no. It was a nice thought. Wait, why are we doing that? It's the bytes. It's going to try other things. I should have hit debug there. Yeah, still past the end. Let's see, Square Bananas. If you add this, does it continue to play nonstop without noise? Well, I can't do that because buffers needed currently doesn't work properly. But I'm sure it would join it without noise. I'm pretty sure the issue is that we're somehow telling F-Audio that the buffer is longer than it actually is. And that's why it's reading past the end. The question is why that is. So I know where the garbage is coming from. It's reading past the end of our pointer. That's for certain. The question is, why is that happening? Because it doesn't make sense. I don't know if this actually matters at all. This average bytes per second. It must matter. I mean, it didn't care what it said, so. Is it block alignment? I think it's block alignment. It might need block alignment to be per channel. Maybe. You know, like, well, I don't know. Could be. Could just be how it does its math internally. Really depends on block alignment being correct. There you go. Block alignment was wrong. Yay! Problem solved. That just means that I really need to be more careful about block alignment. Okay. Manufacture block alignment anywhere else. Block alignment channels times sample bits divided by 8. Yeah. So this was doing it properly. Simon, I blinked and that was the fix in summary. The fix in summary was that the block alignment was wrong. I had a block alignment as 2, which is, yeah, one sample of one channel is 2 bytes. But since it's stereo, the alignment is for 2 channels, so it needs to be 4 bytes. A block of audio is 4 bytes, not 2 bytes. That's why I was reading it twice as long. Very simple in the end, but maybe, and notice how we think of everything else. It must be maybe F audio plays noise at the end of it and doesn't handle silence well and all kinds of other garbage, but it was a very simple thing in the end. This was wrong. So yeah, so that unit test works now. I can go back to fixing that unit test to what it was before. So I changed all kinds of things in here. So back to the original unit tests, run it. It should totally work. Unit test works. Perfect. So that gets us there. But we're running out of time. I got 4 minutes left. I have a hard out, unfortunately. So this sucks because buffers needed is still broken. This technically is also still broken because I can't do what I'm doing in here. Like I can't just, where was it? Yeah. What's the name of the function? Pen buffer. I can't just pick any of these out of here. I need to get one that's the right, number of channels. I mean, actually, no, actually, that's not true. As long as the size and bytes make sense, the rest of it does not matter. Wait, is that true? I mean, that's technically true. This kind of makes the argument for this shouldn't be an array of buffers. It should just be an array of memory. Because the buffer doesn't produce anything for us here. It's just chunks of memory is all it is. Because it just needs a chunk of memory. The buffer itself is irrelevant. It just has to have enough to be able to put it back into the list. Because we pass this structure through. This is what we pass through. And all that has is the pointer to the data, the audio bytes, and really that's it. Like the rest of it is nothing. Loop, all that's unnecessary. So let's see if we can do this really, really quick. Instead of this being that, I'm gonna make it something else. I'm going to create a new struct called RAL buffer. It is just going to be the memory and its length. It doesn't need to be anything else. This is going to be an array of raw buffers. Because that's all it needs. And then I'm going to change this to just do that needs to do, and then delete. Nope. Nope. It's kind of confused, huh? And that's better. So it's just looking for a length that makes sense, and everything else is fine. Doesn't need to do that at all. All it needs to do is raw equals new raw buffer, data equals malloc size. What is it, a byte pointer? Yeah. So instead of doing that, what I'm going to do here is I'm going to make a new structure here. Nope. my mind, I always go back and forth. Is memset faster or is just setting individual things faster? It probably shouldn't matter. So that's the only thing I need to do there. Store my raw pointer. And then the callback way up here somewhere. I put that. Yeah. Okay. That should all work. I'm just gonna run it. I'm confident it's gonna work. So work. I didn't hear anything though. That's disturbing. I mean, I got too confident. So I broke it now. What did I miss? Okay, context, audio bytes, everything is fine here. V buffer set, passing buffer. What did I miss? Missed something simple, I know it. Nope, don't want to do that. Come on. This just needs to work. Oh, that's what it is. Duh. It was saying if free equals null, it was looking at the function name free. So yeah, okay, so that's fixed. So this now works properly because it just finds a raw chunk of memory. You know, this raw buffer is just a chunk of memory with no format or no other data structure in it. And that's all it needs in order to make this work. And it doesn't care what formats are or anything. It's just, is it long enough to fit my data? That's all that matters. So yeah, okay, so we have an implementation here that works. Data here cannot be 0. Fuck off. All right, so where does that leave us? All right, so where does that leave us? So we got further. We got this all straightened out. It just took 2 hours, which totally sucks. I was hoping I'd be done with this thing by the end of here, but of course it's going to take longer. I'm going to have to spend a little bit more time on this. If I get time today, I might jump back on stream later today, maybe. I always say that, but I always run out of time. But yeah. But again, everybody, you know, thanks for watching. You know, follow us on Twitch and YouTube. That helps us. Also, if you feel inclined, you know, donate to the MonoGame project. You know, we're trying to preserve, you know, code first kind of, you know, game development. We actually write code, not drag little boxes, where you actually write code, not just talk to an AI, and learn low level stuff like how things actually render, you know, how to handle graphics resources, how to talk low level to, you know, audio systems like we are right now. Those are the things you learn here, which we think are kind of fundamental things that you really should know as a game developer, of how those things work and not just depend on some high level engine to do it for you. So we think that's useful, you know, to learn those things. And that's what we're trying to promote. So donating to us kind of helps us run the project and keep things going. so that you have a nice high level library that you can still get into the weeds and go down to the low level stuff, but it provides enough that lets you get started and write 2D and 3D games. So hopefully, this stream was helpful to you guys, and we'll see you guys later. Bye.